Okay, guys, in this lesson, we're going to talk about the three different forms of linear equations and the attributes or traits that each of the forms brings. So let's first talk about slope. So any time that we have a constant rate of change called slope, we know that we have a linear function. So there are four states of slope, and remember we always read graphs from left to right. So as we trace this graph from left to right, we are going in a positive direction. When we trace this line left to right, we are going in a negative. We're going downhill. When we are going straight across horizontally, we are not going up or down, we're just staying constant. Our slope is called zero. And when we have a vertical line, which we know is not a function, we define the slope as undefined. Okay, so let's talk about slope as a ratio. So the slope is the vertical change, the rise, compared to the horizontal change. So we use M for slope, and we can pick any 2 points on our graph to find the constant rate of change. So if I pick this point and this point, we're always going to start with the leftmost point. So how are we getting from this point to this point? Well, we're going to look at the vertical change first. So we're going to go down 2 and then to the right 3. Down 2 and right 3. Down 2, right 3. So our slope is down 2 and to the right 3. I could have chosen this point and this point. Let's look at that ratio. So the vertical change is 1, 2, 3, 4. And the run is 1, 2, 3, 4, 5, 6. So we have negative 4 over 6, which simplifies to negative 2 over 3. So it's called a constant rate of change because it doesn't matter what 2 points we use, it is going to simplify to a constant number. Here is our formula. So if we don't have a graph, we can use this formula. Remember, our y's represent the vertical change and the x's represent our horizontal change. So our formula is y2 minus y1 over x2 minus x1. These subscripts are just the ordered pair number. So when we find slope, we need 2 ordered pairs. So for example, if we have these 2 points on a line, this is going to be x1, 5 will be y1. And then we have our second ordered pair, so this is x2, and here is y2. So that's where the subscripts come from. Let's find the slope of the line that passes through these 2 points. So I'm going to identify what each value represents, and then just simply plug it into our formula. So y2 minus y1 over x2 minus x1. So we get a rise of 6 and a run of 4, and we simplify that. Do not turn it to a mixed number. Just simplify and leave it improper if it is. 3 over 2. So that's up 3 and right 2, up 3 and right 2. The second part of a linear function is we can identify if a point is part of this line. So if we don't have a graph and we are asked, is negative 3, negative 1 part of this function? Does this line pass through this point? We simply plug in the values. Be careful with this negative that's part of the function. My x value is negative 3. On the right, we're going to say negative times negative, that's positive 3. And negative 1 equals negative 1. That is a true statement, so we're going to say yes, this line passes through this ordered pair on the graph. Okay, here are the 3 types of linear equations. We have slope-intercept form, y equals mx plus b. It is called slope-intercept form because it provides the slope and it provides the y-intercept. Remember, your y-intercept is when x is 0. So this value is the y coordinate of your y-intercept. If I have the slope and I have the y-intercept, I'm going to use this form. Even if I don't directly have the slope, but I have 2 points and one of the points is the y-intercept, we can use our formula to find the slope and then identify the y-intercept value. That is when x is 0. If we do not have the y-intercept, but we have 2 points, we are going to use point-slope form because we can find the slope when we have 2 points, and then we'll use one of the points to plug in here and here. So let me back up for just a sec. Notice that point slope can be written in this form or this form. These are equivalent. What they have done is they have already added y1 to both sides. And so that's why we have plus y1 in this formula. So either one of these will work for point slope. You will put in your slope for m, and then let's say that x is 3 and y is -5. We would simply put in the 3 here where x1 is. Notice it's minus on both. And then we would put in -5 here or here, depending on which one you used. Then we have standard form. Standard form is used to find the x and y intercepts. So the points that cross the y-intercept and the x-intercept. And then all we have to do is connect those two intercepts to draw our function on the graph. Remember, the x-intercept is when y is 0, and the y-intercept is when x is 0. Okay, now let's talk about slope-intercept form. Like we said, in the name, it tells us that we are provided the slope, the constant rate of change, and it provides the y-intercept, where it crosses on the y-axis. This is in slope-intercept form because y is isolated. Y is by itself. So I can immediately identify my y-intercept as 0.05. So we will graph 0.5. And then we will use our slope, -1 over 3. So when I have a negative slope, I just attach it to the vertical movement, the rise. So we're going to go down 1 into the right, 1, 2, 3. Down 1 into the right, 1, 2, 3. We could also reverse it to see what it looks like on the left side of the y-axis. So instead of down 1 and right 3, we can go up 1 and left 3. Up 1 and left 3. So you can see that these points all line up to create our linear function. Okay, now let's talk about point slope form. Point slope is when we can identify the slope and we have one point which is not the y-intercept. If you have the y-intercept, you're going to want to use slope-intercept form. Point slope means we have a point and we can identify the slope. So both of these versions are equivalent. You can see that in the second one, they have added the 4 to get this one. So we're going to stay here, and I'm going to use this one. And now we are going to continue to put this in slope-intercept form. So I'm going to distribute the -2/3. And then we're going to combine -2/3 plus 4, and this is going to give us 3, so a +3 and 1/3. And so now we're going to plot at 0, 3 1/3. So 0, 3 1/3. So a third is less than a half. And then we're going to go down 2 units. So 1, 2, and to the right, 1, 2, 3. Now let's go back up and let's reverse the slope. Let's go up and left. So up, 1, 2, and to the left, 1, 2, 3. And now we have our linear function. Okay, standard form. Remember with standard form, our a and b must be integers. A is the coefficient of x, and b is the coefficient of the y. We are going to find the x and y intercepts. So first, I'm going to plug in 0 for x. And so when I plug in 0 for x, it wipes out. And so we're left with 5y equals negative 10, because negative 2 times 0 is nothing. And now y equals negative 2. So we can plot 0, negative 2. So this is our y-intercept. That's when x is 0. So 0, negative 2. And now I'm going to find the x-intercept by plugging in 0 for y. So when I plug in 0 for y right here, 5 times 0 is 0. So I have negative 2x equals negative 10. I divide by negative 2, and my x value is 5. So 5, 0, and all I need is 2 points to create a line. Now, if I wanted to know the slope of this line, I can simply count the rise over the run, starting with the leftmost point. So this is 1, 2, and over 1, 2, 3, 4, 5. So our slope is 2 over 5. So in summary, the attributes or traits of slope-intercept form are: we can identify the slope and we can identify the y-intercept. Slope-intercept is used to graph easily. Point-slope form means we have the slope, or we can identify the slope between the 2 points, and we know 1 point on the graph. And that point is not the y-intercept. If we have the y-intercept, we're going to use slope-intercept. So point-slope is when you do not have the y-intercept coordinate. And remember, the y-intercept looks like 0, 2, or 0, 5, or 0, negative 3, and so on. Your x value is 0. That is your y-intercept value. Standard form,